This video is about the Lepton Epoch. In this video, we're first going to get a sense of what was going on during the Lepton Epoch. So we're just going to take a look around at the various particles jostling against each other. Then we're going to take a look at the end of the epoch when a special annihilation event goes down. Finally, we're going to consider what the significance of the particular photons that were created in this final annihilation event actually is. Let's get into it. First, let's take a look around at this Lepton Epoch. And before I get started with that, I just want to mention why we call it the Lepton Epoch. The Lepton Epoch comes on the heels of the Hadron Epoch. The Hadron Epoch is when larger particles were created out of quarks, such as protons and neutrons. And as those began to annihilate each other, eventually it reached a point where instead of quarks being the dominant mass form in the universe, leptons became the dominant mass form. And at that point, slightly before 1 second, is when the Lepton Epoch begins, when leptons, specifically electrons and positrons, become the dominant mass form in the universe. Now let's get a sense of this Lepton Epoch. So the Lepton Epoch traverses the time period from slightly before a second, but we're going to put that timeline at 1 second, even though it starts slightly before 1 second, because that's where the cosmological timeline has it. So I'm just going to run with that. But really, it begins slightly before 1 second. From 1 second until about 10 seconds, when the Lepton era ends, we have a universe that goes from a size of 10 to the minus 10 of our current universe size to 3 times 10 to the minus 9 of our current size at 10 seconds when the era ends. And similarly, the universe passes from a temperature of 10 to 10 Kelvin at 1 second to 3 times 10 to the 9 Kelvin at 10 seconds when the era ends. Earlier in the universe, prior to the hadrons forming, the universe had been filled with a quark-gluon plasma, and at this point, we no longer have a quark-gluon plasma. Instead, all the quarks that we have been locked into triplets, and all the gluons that we have are in those triplets, in those protons and those neutrons, holding those quarks together in those protons and neutrons. Also at this point, the neutrinos are flowing freely through the universe. It's not dense enough for them to be blocked. However, the radiation is still converting between electrons and positrons and radiation, because the radiation is still high enough energy to spontaneously create these lighter particles. Despite the density being sufficient for neutrinos to be flying freely, photons are not flying freely. There are electrically charged particles that are constantly blocking the photons from getting very far. As the universe goes through this period, as it expands, the temperature is decreasing and the density is thinning out. And that brings us to the tail end of this epoch, where the temperature has reached a low enough point that the radiation can no longer spontaneously turn into positrons and electrons. At this moment, in every cubic centimeter of the universe, there were roughly 2 kilograms of electrons, 2 kilograms of positrons, and 2 kilograms of radiation, and a measly tenth of a gram of protons and neutrons per cubic centimeter. And the universe was about to reach the critical temperature of 4 billion Kelvin. As the universe traversed this boundary at roughly the 10-second mark, there was a 5-second period of positron and electron mutual annihilation into radiation. Afterwards, roughly 1 in a billion electrons were left, but there were no positrons, and we don't know why there was this difference between the electrons and the positrons of 1 billion and 1 to 1 billion, such that when they all destroyed each other, there was an electron left. There were 1 in a billion electrons left. That remains a mystery. Before we close this video and move on to the next epoch in the universe's history, the one known as the Photon Epoch, the photons that were created in this final annihilation by the electrons and positrons call for our attention. Until now, the radiation had been interchanging between radiation and particle type regularly. But at this point, when we reached a temperature of 4 billion degrees such that the radiation can no longer create positrons and electrons, and it can no longer create any kinds of particles at all, we leave the time period of photons spontaneously creating particles, and instead we're left with these photons for the foreseeable future. And these are the photons that are going to wait around and get dimmer and dimmer as the universe expands, and eventually 380,000 years in will be the photons that make up the cosmic microwave background that we detect when we look everywhere around us. So that's the picture of the Lepton Epoch. In the next video, we're going to take a look at the beginning of the next epoch, the Photon Epoch, which begins at roughly 10 seconds into our universe's history. Till next time.